Okay, so for our first one, okay, we're looking for the number of moles. Okay, so this is another example of one of the easier ones. Okay, of CaCO3, so calcium carbonate. Okay, so when we're looking at that one, we're going to have 40.08. That's our calcium. Okay, 1 carbon, so that's 12.01, and 3 oxygens, 16 times 3. 40.08 plus 12.01 plus 16 times 3. Okay, so 100.09 is our molar mass for that one. Okay, everybody all right so far? Okay, so the other thing, they tell us the mass, 125 grams. Okay, so we're looking for number of moles. N equals little m over big M. So that'll be 125 over 100.09, so it's going to be like 1.25 probably. Okay, so 125 divided by our answer there. Yeah, 1.25. 1.25 moles. For that one. Okay, questions on the first one? Don't be afraid to ask here, guys. Guys, it is crucial, and I'm just looking at quizzes here right now from this morning, okay? It's crucial that we do this part right, okay? It's impossible to get the rest of the question right if we're not getting the molar mass right, okay? Make sure that you're dropping and swapping if you have to. Obviously, we didn't on this one, okay? To get the correct formula, okay? Being able to write chemical formulas is crucial for reactions and mole equation. Okay, and then that we're going piece by piece to get the total molar mass. Okay, 1 calcium, that's right here. 1 carbon, that's right here. 3 oxygens, there's my 3 oxygens. Piece by piece by piece, add them together. Okay, I'm going to do delay on the second one. Okay, let's look at the second one too. Okay, so we're looking for the mass. So we're looking for little m of 2.7 moles. So they gave us N of lithium phosphate. That was, we had that on the quiz. Okay. Li3P. Okay. So we've got 6.94 plus, times 3, because there's 3 of them. Okay. Plus 30.97, 57. Okay, 6.94 times 3 plus 30.97. So we're looking at 51.79 grams per mole. Okay, so if I want to solve for mass, I have to manipulate the mole equation for little m by multiplying both sides by big M. Okay, so little m will be 51.79, that's big M, times N, 2.7 moles. Okay, so we're looking at 139.83. 0.83, what are my units? Grams, yeah, because I found mass. Okay, always make sure you have units on your answer. All right, give you a couple more minutes on 3 and 4. Okay, let's have a look at how many people have done number 3. Okay, let's have a look at number 3 for sure then. Yeah, I was recording that the whole time, so there's going to be a big gap where nothing happens. Okay. All right, so for number 3, we're looking for the number of molecules. Okay, they do tell us the material. It's iron 3 oxide. Okay, so we got Fe2O3. Okay, so that's going to be 55.85 times 2. So there's our 2 irons. Okay, plus 16 times 3 are 3 oxygens. All right, so 55.85 times 2, okay, plus 16 times 3. All right, so 159.7. Okay, grams per mole is going to be our molar mass for that. Okay, and they tell us the mass, 230 grams. All right, so if I want to find the number of molecules, I'm going to need to use Avogadro's number. Okay, and I'll use it by multiplying it by the number of moles. Okay, if I find the number of moles and I multiply by the number of molecules in 1 mole, then I'm going to get the number of molecules. Okay, so that's the next thing I've got to find is the number of moles, which is pretty easy. I've got the 2 numbers I need, 230 grams, little m, divided by 159.7, big M. Okay. So 230 divided by 159.7. Okay, so 1.44 moles is what I've got here. Okay, so now that I've got that, now I can find the number of molecules by taking the number of moles and multiplying by Av's number. Okay, we said that's what we do before. Okay, so that's going to look like this, 1.44 times 6.02 times 10 to the 23. Now make sure that you're not rounding off. Okay, I'm keeping all these decimals here when I multiply by Avogadro's number. Okay, so that's going to give me 8.67 times 10 to the 23 molecules. Oh, and I didn't put units on that. Molecules. Okay, questions on number 3. Right? How many people? Oh, right, please.
Can you tell how to times it by Avogadro's number or divide it?
I have to think logically about it. Okay, so the logic here is that if Avogadro's number tells me how many molecules are in 1 mole, and I multiply by how many moles I have, that should give me the number of molecules. Okay, in the same way that if I want to know how many donuts are in 4 dozen, I go 4 times 12. I take the number I have, 4 dozen, and I multiply by the number in a dozen. Okay, same operation here. I'm multiplying how many moles by the number in 1 mole to get the number. Yeah? Okay. All right, how many people have done number 4? Okay, let's have a look at number 4 then. Okay, so for number 4, we're looking for, so they're giving us the number of molecules. 5.42 times 10 to the 21. Okay, so less than a mole, significantly less than a mole. Okay, and they're telling us the material. Okay, nickel 2 nitrates. Okay, now when I'm doing the molar mass for this, I got to really be careful about counting up my atoms correctly. Right? How many nickel atoms are there here? Just 1. All right, so that's going to be 58.69. Good thing I checked. Okay. Plus, how many nitrogens? 2. How many oxygens? 6. Okay, how did I figure that out? Well, the brackets say multiply everything behind me by 2. Okay, so there's 2 nitrogens, 2 times 3 is 6 oxygens. That's where I get that number from. All right, so my molar mass, okay, 58.69 plus 28.02. That's my 2 nitrogens, plus 16 times 6. All right, 182.71 grams per mole. All right, so I've got big M, I've got the number of molecules, looking for little m, which means I need N. I need the number of moles. And I can get that by doing the reverse of what I did in the last question. Okay, if I want to find N, N means taking the number of molecules and dividing by Avogadro's number, which is the number of molecules per mole. Okay? Okay, and so what will happen is, okay, my molecules will cancel and I'll be left with moles. So I'll have 1.5, sorry, not 1.5, 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. So 5.42, 21, okay, divided by 6.02, 23. All right, so there's my number of moles. It's really small. That's okay. It's significantly less than a mole. All right, now I'm going to take that number, that's N, 0.0009, or 0.009. Okay, and now I'm going to use the mole equation. N equals little m over big M. I have N and big M now, so I manipulate in the only way we ever manipulate that formula, okay, to get M by itself, little m by itself, that is. Okay, so I'm going to have my 182.71 okay, multiplied by 0.009. So here's big M, here's N. Okay, so we're looking at 1.64 grams. Okay, for my mass on that. No.
If we already know that m times n equals little m, do we still have to write that formula? Or
Here's how it works. If all you write is your answer, and it's right, you get full marks. If all you write is your answer, and it's wrong, I can't give you anything, because all I see is a number that's wrong. So my advice would be, show all your work.
But
okay?
just for that part, like if I'm finding little m, and in that case it was 0.009 times 182.71, do I have to write m times n equals little m before that? Or can I just?
Well, I give you a mark for the manipulation, and I give you a mark for plugging in the numbers. So again, my advice would be show everything. You just never know if you get clumsy fingers on the calculator and you lose a mark for your answer, right? Well, but you knew how to do the whole thing. You showed me all of that, right? I only have to dock you 1 mark then because you're clumsy on the calculator as opposed to didn't show me anything and I don't know whether you knew it or not. Okay. And I would hate for that to happen because I had that happen to a kid on his final exam once. This kid I told all semester long, show your work. I don't need to show my work. I don't need to show my work. And I'm like, you're a smart guy. You're probably right. You don't. Final exam, he got his calculator cleared. It doesn't go back into degree mode. He didn't put it back in degree mode. Every question that involved using trigonometry, he got wrong. And he didn't show any of his work. 6-mark question, 0. Right? 5-mark question, 0. Right? That sucks. He's a smart kid. He didn't deserve the mark he got, but I couldn't give him anything because he didn't show me anything. And all I saw was the wrong answer. And that as a teacher is typical. Okay? So, moral of the story, show your work. Okay? Can't go wrong by showing your work. All right. So, yesterday we were working on some mole equation stuff. Okay, and I want to just kind of finish that up, make sure we're practiced up with that. There really isn't anything else to show you. There's 4 ways to ask a mole equation problem. I'm going to ask you 4. 3 or 4 on your unit exam, okay? These are the 4. Right? Make sure you know how to do these ones and you're set for those. Yeah, I'm going to go over I'll give you a pretty good detail of what's on the test tomorrow, but suffice it to say, the practice test, that's what your test looks like. So there's some multiple choice, and there's some written response, and that's basically the skeleton of the test. Okay, so your practice test is basically an old test I don't use anymore. Okay, that's the skeleton of the test. All I do is I change the muscles and flesh. I don't change the bones. Okay, so that's what your test will look like. Gives you a pretty good idea. Okay, I would like you guys working on, okay, in your digital workbook, there's a stoichiometry worksheet. It's got these long wordy problems, but okay, they're still mole equation problems. So like for question number 1 here, it's got a lot of extraneous information. In the metallurgy of iron, the iron ore, which is Fe2O3, is converted to iron and carbon monoxide by reacting the ore with coke, which is pure carbon. Does any of that matter? Not at all. Okay, all you need is this formula and the fact that there's 0.580 moles of it. Calculate the mass. Okay, it's an important skill to be able to read through a problem and get what you need from it. Okay, so that's kind of what these are about. So you guys can get to work on these. I'll leave them up here on the board. Obviously the answers are there in bold at the end, so you can check and see if you did them right. And then please ask. If there's one that you're not getting, okay, ask. You can do it together here on the board. There's no shame in that. Okay, we just want to make sure everybody knows what they're doing on this. Okay, all right. Okay, so number 3 is a lot like the oxygen one we did at the end of the day yesterday, where we were telling the difference between a molecule of oxygen, which is O2, and single molecules of oxygen. Okay, this is the same because phosphorus is a molecular element. Okay, when I look on the periodic table, okay, I know that phosphorus comes this way. But when I look at the molar mass, or sorry, the atomic mass for phosphorus, it's not for P4, it's for one single atom. That's why on the periodic table it's called atomic mass versus molar mass. Okay, the molar mass of P4 would be 32 or 30.97 times 4, right? But if I want to find out how many atoms there are, I'll use the mass, the atomic mass, the mass of one atom, which is 30.97 grams per mole. Okay, so I know that's the mass of 1 mole of just phosphorus atoms, not phosphorus molecules. Okay, now they're telling us that we have 77.5 grams of that. Okay, and so now I can calculate the number of atoms by first calculating the number of moles. So take my mass, 77.5, okay, and divide it by 30.97. Okay, so I got 2.5 moles of this stuff. All right, I want to calculate the number of atoms, so that means that I take N and I multiply by the number of atoms in 1 mole. Okay, and so that's going to be 2.5 times 6.02 times 10 to the 23. Okay, and we're getting 1.51 times 10 to the 24 atoms. Okay, does everyone follow the difference there? You could have also done this by multiplying that molar mass by 4, doing these same calculations, but with that mass multiplied by 4, you would have calculated the number of phosphorus molecules. And then to get the number of atoms, you would have had to multiply that number by 4. And you would have got this same number here. Okay, it would still work. I would suggest this is probably the faster and easier way. All right, any other ones giving us trouble? Okay. Also, guys, remember that today will be your last chance to come in at lunch and see me for help before your unit exam. So if there's anything that you're wanting to go over or get some tips on or whatever, okay, today's your last lunch hour to come and see me before your exam. Incidentally, about the exam, I will let you start early. Okay, so I'll make sure that I'm here the room is open and all of that, and let you start your test at, let's say 8:15. That gives you an extra 20 minutes, okay, to write the test. You shouldn't have any trouble writing the test in an 85-minute period, okay, but I'll give you an extra 20, okay, if you need it. Of course, if you have an allotment for extra time, you'll get that anyway, okay, but I'll do that. So, I'll talk about that tomorrow. I'll go over what the test looks like tomorrow. Okay, let's get everybody to pack up here, and we'll spray off desks and get everything ready to go.